Welcome to episode 3 of AI Chronicles. I'm Sonam, and today I'm here with Connor Shorten, a research scientist at Weaviate. It's a vector database company if you don't already know it. I have followed Connor's work at Weaviate on Twitter and LinkedIn from quite some time. He and his team have been doing some really cool work in the realm of vector databases for building large language models and um, retrieval augmented generation applications, and just you name it. However, before we dig into it, and I make Connor talk a lot, I found out that Connor loves playing basketball, and his passion for AI has stirred up some funny ideas in his brain. So, Connor, why don't you share one of those funny ideas with the audience?
Awesome. Sonam, firstly, thank you so much for having me on the podcast. I'm so happy to be on the third episode and be on like a podcast that you're kicking off and be early on it. And we recently had Charles Pierce, who is my second podcast guest on the Weaviate podcast, back for the 69th. And I hope that we have a similar thing because it's pretty cool to have like be early on the podcast. But yeah, so
Yeah.
my my basketball story is yeah, so that's kind of how I got started with machine learning. Is I was I played basketball in college, and then I was taking computer science classes, and I was trying to like classic hacker, like how can I build an app that makes me a millionaire in like 2 weeks?
Of
It's like
course, of
of course, of
course.
course.
Every computer scientist's dream.
Yeah. So I was I had this experience where like when I was in high school trying to get recruited for college basketball, you would have like highlight reel tapes that you'd send out, and you'd like pay someone to cut up your games for you. Sometimes like you
Hmm.
might do it yourself, but there are a lot of like camps that kind of couple this service where they also produce the highlight reel. So my thinking was like we could use these convolutional networks to segment out the like the made baskets, and then and
Oh
then
my
Silicon
gosh.
Valley to the to the moon. But from doing that, I learned like how challenging it was to create like a big enough data set. Like at the time, you had to have like so many labeled examples to make that kind of thing
Mhm.
work. And so that got me into data augmentation, and then that got me into like having an academic advisor, and then I just kind of fell in love with like reading papers and sort of lost the Silicon Valley dream for a while, just reading papers all the
Fell in love with reading papers. I thought I'd never hear it from anyone. But hey, I totally agree with you. Some of those papers, they do make you fall in love for sure. The
time.
others, it's just like, question, why are you doing your PhD again? Yeah, the question I deal with every day. But yeah, thank you so much for sharing your fun story and how you got started in this field. So that's very cool. All right. Well, are you ready to talk about VV8 and the research you are involved in? Awesome. Let's start with very general questions. Like, how long has it been that you have been working there?
Oh, it's been about a year and a half. I think for me, I definitely spent the beginning half of working at Weaviate just super interested in the search stuff. So I was
Hmm.
like, I was really interested in re-ranking. I thought that was quite cool. I still think it's cool, but like that's how
Yeah,
I spent most of my time. And then the kind of the language model stuff has really super changed like the day to
I
day.
totally agree. Yeah.
And then yeah, I've actually been getting more interested in I've started doing work within the company on the approximate nearest neighbor stuff and like HSW and really thinking about those kind of algorithms. And then I've started an interest in databases, but I don't know if I should talk too much about it because I'm not like an expert on it, but it's a lot of fun.
Okay. Awesome. And can you describe VB8 in one line for the audience?
Yeah. So when you asked me that question, I thought it was a pretty like it's a tough question to answer. But we recently had like a company meeting, and Bob gave a lot of like clarity on this topic because I think it's a big thing. Like, what is one sentence to describe Weaviate, and then you're kind of like differentiating yourself with other vector databases, and so it is quite a question. But I think the answer for that is customizability, and that's kind of the key differentiator of Weaviate, the key focus of it right now, which is like there are so many levels to think about customizing your vector database. There's like, this kind of optionality of which model you're using for say embeddings, like, OpenAI, Cohere, or Hugging Face, or, your own model that you trained. And then there's the same kind of optionality with because vector databases are kind of like we have this module system in Weaviate that kind of makes it like an inference platform. So you have
Mhm.
kind of like the core value in the data, and there we can talk a little more about like you have like the vector index, but you also might have like symbolic data structures, like say you have like the keyword scoring, like inverted indexes for BM25s, but you have like different data structures around your core data, and then you have like these
Right.
modules for like how you process queries around it. So the most common flow is like you have a query and now you need to vectorize the query to look in the vector
Mhm.
index and then get the results and pass that to the language model. But so there's like, I think with Weaviate there's like this flexibility of there's all sorts of kinds of ways that you can use it, and then there's also all sorts of ways that you can run it and host it and things like that. So you have like the Weaviate cloud service, and then you have like Docker containers, Kubernetes, and like Helm charts and
Mhm.
things like that. And then you also have like Weaviate embedded that you can put in a Python notebook. So it's about kind of like that, covering all sorts of different ways you want to use it, as well as like, I think what we're the evolution, the sort of next step is the customizing of the indexes. So we have like PQ, and this is like a product quantization. It's like a way to compress your vectors. And so you
Right.
like might need to use that or you might not need to use it. So it's the same kind of thing where it's like tuning it to your data. That's what I think is kind of the future direction of this.
Customizability, I like that. It speaks to the customers too. I guess customizability, if you have that feature, it makes life much easier for everyone. Very cool. Um, so according to you, what do you think are the two top aspects of VBA database that you like, and one aspect you think might need more improvement?
Well, I think it's kind of the customizability is probably, well, it because yeah, it's like open because it's nice to be able to have it be open source, and then when people are like,
Right.
how do I run it? It's like, instead of just saying, here's the free cloud tier after 14 days, get out of here unless you have a credit card ready. You also can say like, well, here's the Docker container if you want to just run it yourself. And so I think that's quite a nice part of it, is that open source. It kind of like that part of the open. There's also like, of course, like the open sourcing of the code, and like some people do want to customize it. Like our last Weaviate podcast was with Kevin Cohen and New May, and they actually did want to like get in there to customize it, and so that's pretty cool. But yeah, so the open source is probably the one thing, and then
Mm-hmm.
the other thing is I think this the module system is quite cool because you don't have to worry about hosting your vectorization inference to query it, compared to like if you have to also figure out now how am I going to stand up a server with my Python model inference compared to Weaviate just kind of orchestrating this stuff for you. So that's probably my two favorite things. And then for the last thing, I'm not going to have like some glaring weakness
Right.
that's something that I
Yeah.
just hate about it, but but I do think this like it's something that we're working towards. Maybe would be a better way for me to phrase it,
Yeah.
but
Yeah. No, I
it is
totally agree. Yes.
yeah, is like this having all sorts of different indexes. So like one example is HNSW, the nearest neighbor search algorithm. You have to like build up this graph and have this graph in memory, which,
Mm-hmm.
and then so then there's another algorithm called diskann. Well, actually, sorry, there's an intermediate thing which is IVF, which is like clustering approaches. So you take
Right.
your query and you like hash it, and then you
Mm-hmm.
would only need to load like that bucket into memory to then search through that
Oh,
bucket of the hash. So diskann is kind of like an intersection between that idea and HNSW, where you have the clusters, but then you do have like in memory graph indexes that you like the bucket isn't, you're not just going to like brute force the bucket. You'd have like a
yeah. Yeah.
graph for the bucket. So there's that. There's also with diskann, there's something to like the PQ, like this kind of like PQ overfetching rescoring thing has been, it's been kind of surprising. Like it makes a lot of sense now that I've seen it, but I didn't see it coming. Where you compress the vectors, and then you can like load the compressed vectors into memory, and then when you need to rescore the list, you can go bring the full precision vectors back into memory just to rescore like the top candidates. And so that this way you kind of have like this you like recover the precision of the search, because it's about like getting in the right direction of the vector space as you're traversing the graph. But maybe
Mm-hmm.
I dove into the details a bit, but the thing that I'm looking forward to is like having more kinds of indexes so you can again like customize the
Right.
index to your data.
Okay. Awesome. Thank you. And I totally understand you digging into details. It's something you're passionate about. So, but yeah, thanks a lot for explaining that. Awesome. So I think it's time. Let's switch our gears and talk about RAG. For those who do not know what RAG is, well, it stands for Retrieval Augmented Generation, and it uses an external knowledge base to keep the LLMs grounded and return the most updated and accurate information. Again, this is the most basic way I could define. We have seen many companies and individuals use RAG as feature to their LLM and other AI applications. So, Connor, so what I want to know from you is that I get that all the LLMs that use RAG, can it be fine-tuned to specific database domains? And if so, how does it impact the overall performance?
Yeah, so this kind of like fine tuning question, I used to ask this on like every podcast because of that. Like, I did my PhD in like, fine tuning with gradients, and I just like,
Oh, wow. Okay.
wanted to fight the zero shot thing till the end and
Right.
try to get people to spin up the PyTorch. But I think there's like three levels to this. Well, so there's like yeah, so this kind of like how do I tune the RAG system? That's definitely like the emerging direction I think is really exciting. We see like Jerry Liu and Llama Index is tweeting a lot of stuff
Hmm.
about like how do you evaluate your RAG pipeline? We work
Right.
closely with like Arise AI, and they have Phoenix, and these are like the monitoring for the performance. And then there's also a framework called Ragus. But yeah, so without doing the list of all the things I've seen, like this idea of like yeah, what are the knobs to tune to get better RAG? And I think so at the highest level, it's like vector search, BM25, hybrid search, and then maybe adding re-ranking. That's probably like the simplest layer you could tune. Then,
Okay.
within hybrid search, you have this parameter alpha, which is how much you weight vector search in BM25. So you might consider tuning that as well.
Hmm.
And then there are things like AutoCut, where AutoCut is looking at the vector distances and it finds like the steepest slope, and so say the steepest slope like drop in the distance from the query to your results is like
Hmm.
it's suddenly it's like 0.99, 0.98, 0.97, and then like 0.88.
Drop. Mm-hmm.
All right.
Mm-hmm.
So you could tune like do you want to do the first cut or the second cut with that kind of thing? So they're like these little things that
Okay.
you can tune like very at the top level. Then you can tune like the index parameters, like with PQ, with P product
Mm.
quantization, you're compressing vectors by grouping the segments and then finding the centroids and compressing them that way. Or like HNSW also has hyperparameters like EF construction, which is like the number of the size of the queue when you're searching, and then you have max connections, which is like how many neighbors each node has in the proximity graph. So so you could tune
Hmm.
that also. So you can like just kind of tune the search index. But then there's kind of like this layer above that, which is like Llama Index and LangChain. They did an amazing job of finding like all these new kind of query engines with LLMs. So there's like, maybe you want the LLM to like reformat the query before you search with it. Like you pass in like your prompt from ChatGPT, and it wants to instead like extract the information need and send that to the search engine. So there's like that. There's like the SQL router. There's like the multi-hop question answering, where it's like, do you need to break this question into two questions? There's like multi-index. Do we want to search through multiple indexes? So there's like this big advanced query engine kind of space. And I'm not sure how you should think about like, how do I tune that for my particular thing?
Right.
But so those are like the easier things you can do compared to fine tuning with gradients. Fine tuning with gradients is like you're going to have a custom language model for your domain, and there's definitely a lot of things happening with that. Like I see a lot of people talking about they want to do either you use RAG to format the training examples to then fine tune with, so in the training data it has that kind of retrieval augmentation, so then it's like a little better suited for what it's eventually going to be
Right.
used for.
Stronger knowledge base, I guess.
Yeah, exactly. Yeah, and so that's quite cool. There's also like the end-to-end RAG, where you put the gradients from the language model back into the encoder, and that way you get like a custom embedding model as well. It's okay. Yeah, so I think it's still early on that fine tuning with gradients thing. I'm not really particularly bullish on it, even though I think it's cool. But like I just think it's easier to tune the search, and I think that For me, the evidence that I've seen in the papers is pretty clear that if you give it like Oracle context, like if the language model has just like the greatest context in that
Hmm.
window, that works extremely well. So I think just tuning the search will get you to where you want to go, and then that's a lot easier to
Right.
manage. Yeah.
So do you think that this addition of RAG to any of these LLM applications, has it made the fine tuning a little bit easier to get to where you want to be? Would you say that?
Yeah, well, so I think two things have happened that's really interesting. So in the
Mm,
past, with evaluating search quality, you would have to have like a pretty carefully labeled data set, because
right.
it's like they use like NDCG instead of just recall would be like, did you like, so recall would be like, you fetch 100, is the gold document in the 100,
Hmm.
and then NDCG is like, you have a relevance label for each of the documents, and then it's like this weighted score. And so
Ah, okay.
it's like less intuitive, but it gives you like a better sense of it.
Old school.
Yeah. Yeah. So that would mean that you would have to not only label like what's the gold document, you'd have to also like sort of rank it.
Hmm.
And so here's what's changing, and why this is actually a pretty exciting space, is because now you have the large language model can kind of evaluate search quality like pretty well. There's a lot of papers on this. I just read a really interesting paper called "Large Language Models Can Accurately Predict Searcher Preferences," where it's like, I find what they're
Interesting.
doing is pretty hilarious, where they have the human ground truth ratings, and
Uh-huh.
then they're tuning the prompt, like, those particular words. Like,
Oh,
have you
yeah.
seen how it's like, take a deep breath and then answer, like how those
Oh
kind
my
of
gosh. Yeah. 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 Yeah.
so they're tuning the prompt until the LLM eval agrees with the human NDCG ratings.
So it's kind of like hard coded. Won't you say that?
Yeah. Well,
Like,
yeah. Like fine tuning could just be, yeah, like a prompt. That, I mean,
mm,
it sounds pretty bizarre. And I've had people, like, when I remember early days when someone would be like, you think prompt engineering is a real thing? And I'd be
oh
like,
man, I think that it's still going on. That's like a whole another debate and discussion for, yeah.
yeah,
I still, I don't know if it's going to last, but yeah, people have theories.
yeah, yeah. I'm not sure either, but I mean, that
Yeah.
prompt breeder thing. So that prompt breeder paper is like they're evolving prompts. Yeah, I don't know. I mean, it's like language models are pretty funny things, and we don't really understand them that well. Like I like Francois Chalet had this tweet about how it's like language models are like a key value store, where you're trying to find like the key. Well, maybe a better way to think about it is like the manifold thing, where it's like, if I crumple up a piece of paper and it's like this set of inputs that the language model can reason about are like points on that paper, and they're like
Mm,
these. I don't have a paper near me to do, but I have done
right.
that on a podcast before. But like they're like,
Understood.
the gaps in space in like the topology way of thinking, like a donut, like the middle of
Mm,
it is like there's inputs that just are not in the space for whatever reason. So I do kind of think prompt tuning will be around for a little while. I'm not sure. Yeah.
right, right. Yeah, no, it makes sense. It's very interesting. So, yeah, so while reading your tweets and some other articles, I came across not just about RAG, but also how people are using what is called generative feedback loops. So I would really love to know your thoughts on it. Like, um, let's just start simple. How would you describe generative feedback loop in simple terms?
Yeah, well, I think, okay, I'll start to describe it in simple terms. It's really as simple as the language model produces new data, and then you save that back into the database, and then you might want to access it later.
Hmm.
So,
Okay.
if you have the language model, you say, write me a report about, how least recently used page replacement works in operating systems, and it writes something, and then you save it back in your database, and then maybe you want to do RAG with that, or you want to search for that, or something like that. So that's kind of like what it is. And so maybe if I could like tell the story a little bit, this was kind of like right after ChatGPT came out, and I was talking to Bob, and we were like, what is our move? What's the biggest thing? And so Bob came
Mm,
up with this idea, and I think like I think it's like, it's like pretty future looking, right? Like it's
right.
like kind of, you could have like simple things where it's like the example we used in the blog post when we launched it was like, it's like personalization. So say your
Right.
software, you release a new feature and then you want to go through everyone in like your customer list and write them like a custom email of why they should like this feature, save that back in the database.
Right.
And that was kind of the first, like the low hanging fruit, or it could be used like for, like filling in missing values in your data, or like transforming your data, in kind of simple ways, like turn this blog post into a tweet, which is quite similar to the other thing. But yeah, so maybe let me pass it back to you before I go any further on this, but that's kind of, that's kind of how I see it. Yeah.
Got it. Got it. And so that's interesting. So do you think building RAG and feedback loops in any application is a good idea? And if yes, will it be easier to scale that application?
I think the intermediate thing here is this like GPT caching idea, where it's like
I see.
yeah. So GPT cache is like, let me remember this. It's it's like oh, okay. So you take the query and then you see if the large language model, like if you've had a similar enough question, and if you do, like based on some threshold, I don't know exactly how it's calibrated, but let's say the vector distance between this query and a query the language model has already answered is greater than 0.95 arbitrarily.
Mm-hmm.
And so then instead of sending this new query to the language model, you instead send the cached answer from the, that other query that you had paid.
Okay.
So that's an example of a generative feedback loop where you're, you've generated this answer and you're saving it back into the database to then use for future question answering purposes. So
Mhm.
yeah, that's probably one of the most practical. I mean, yeah, that's probably like one of the things we're seeing happen, but that kind of like offline processing of like writing, writing personalized advertisements for everyone in your customer list for your new feature. That's more so what I hope to see get more popular, because it's so exciting. And I think it's like this thinking. So for me, like what really inspires me with this thinking and vector databases more broadly is like, what does like a quadrillion scale vector search
Wow.
look like?
Yeah. Yeah.
Because
Yeah.
yeah, yeah. Because that's kind of like the point of HNSW, is that it's like, polylogarithmic scaling of searching, and like so you could search a gigantic thing, which is kind of hilarious, because we're kind of rolling out like brute force indexes, and coming back to my earlier thing of like of letting you customize the index type, because we like there was a lot of fire on Twitter about like new vector database NumPy, right? Because you can just like brute force at the scale that like most people are dealing with. But
Mm-hmm.
I mean, there are problems with that. Like, it doesn't help you do like the cloud scaling and the hosting and all that other stuff that like the production ready vector databases work on, but or the query interfaces. But anyways, but so that kind of thing of like, so what is like the new applications unlocked by absolutely massive scale vector search? And so there's obviously like the enterprise thing. Like a lot of big companies, they actually do have this kind of like billion, trillion scale. A trillion is extremely rare, but it has been seen before. But I think this kind of like language models, generative models, just like, exploring your data, generating new things, maybe in like multi-agent frameworks where they role play and talk with each other and stuff, to like just blow up the size of your index such that you have like a quadrillion points of like generated data, and now you need to like search through it and find something useful in that. I think that's kind of the exciting. It's like I like to compare it to the Rick and Morty episode where they have like the multi-dimensional cable thing.
Yeah. Yeah. That's a good analogy. Yeah, totally. That makes sense now. Yes. Awesome. So, I was thinking about what you said about the quadrillion data points. Do you think that these loops can address the issue of the query ambiguity and help in refining
Hmm.
them?
Yeah, well, I think that one, you've caught like a gap in my knowledge that I'm actually extremely curious about, which is this paper called Instructor.
Right.
And the reason I think it's so well, okay, so to answer your question, there is kind of this simple one where it's like, you could have the language model like process a query and like reformulate it, or try to extract an information need from it, and then maybe you use that query and the information need as the input in that
Mm,
like cross encoder re-ranking setup, something like that. But there's a paper called Instructor, where it's like you're searching for like particular relationships of the query to the search result. So I like to use this with like the e-commerce thing, where it's like if I give you the shirt into a vector search database, most of them are just going to return you like a shirt that looks exactly like this, right? And but you might be wanting like, I want like something that complements this. There's like a
right.
paper from Amazon on this kind of thinking of like, you want like exact match, or you want complement, or they have like two other things that
Mm,
I can't recall. But like it's like you're searching for like a particular relationship of the thing to the query, not just like semantic similarity. And I'm really not sure exactly what that ends up looking like. Maybe that's where like the graph stuff comes in, because graphs are like supposed to capture a particular kind of relationships and maybe have like a particular
right.
kind of relationship embedding. But yeah, so that kind of query parsing, that's a really great question. And I do think the LLMs probably can just like put a band-aid on it, but there's
Yeah, for now, I'm sure until an actual fix comes up. Okay, awesome. So, yeah, so last but not the least, I bet you like this question, I think. Tell me about your new research that you and your team are working on gorilla. And why gorilla? Why the name gorilla? I'm curious.
well, we didn't come up with the name gorilla. It comes from a paper from UC Berkeley, which was their gorilla LLM. I don't know why. I guess it's like a gorilla is I've come to like the gorilla because of this reason. It's like a gorilla is like super strong, right? But it
Yeah,
and it's like like it's like
people
if
are
you were
creative.
it's like if you were to hook it up with tools, it could be, I don't know,
It
something
becomes
like that.
more powerful or like super gorilla or something with all those
Yeah.
enhancements. Got it. Okay. Yeah. So yeah, please
It,
tell me about your research.
because that's I think the right way of thinking about it, because I've thought about it from several angles. I thought about it, so basically what it is it's text to graph. I've read the original gorilla paper from UC Berkeley is about taking a natural language command and then finding the machine learning model that you want to
Mm,
use, and then formatting the particular API to call that inference from like the Hugging Face model hub. And that's awesome, but I've kind of repurposed it for Weaviate's sake to do like text to GraphQL. So Weaviate has a GraphQL API that lets you
mhm.
access all these different kinds of searches. So I took a few perspectives with that. The first one was like I was like, oh, we're gonna build this auto API, and it's gonna be so cool because if you're a new Weaviate user and you don't know how to use GraphQL, you can just type in the text and then it will write the GraphQL for you, and then so you can have your queries answered while also having this like lookup to start like learning it. But I actually
Exactly.
think that's the wrong the
Oh,
wrong way of thinking about it.
oh,
And I
okay.
and I and I learned this from reading that Mem GPT paper that just came out, which is like in MemGPT, well, yeah, I'll tell the story this way. But in MemGPT, it's like you have explicit sections of memory in the context window. So maybe if it's like role playing, it's like you have or yeah, like you have the window where you describe the tools you have access to, as well as the window where you have like the current context for like what you're currently doing. But you kind of separate it out like this, and so I think the important thing then is how do you tell the large language model it has access to the Weaviate tool in as few tokens as possible? You don't want to do this OpenAI funks approach where you have to have this
Right.
gigantic JSON dictionary where
Yeah.
I don't
Yeah.
hate that. I don't hate that idea, but like
But
for some, yeah.
life could be simpler.
Yeah, for some things it definitely works. But like Weaviate has so many APIs, and it's like for the language model to like fully realize the Weaviate, it has like a succinct text prompt that tells it like you can search with like BM25, hybrid search, vector search, you can re-rank it, you can add filters, like it has this natural language description of the class. And then from there it can output like a natural text of how it wants to use the tool. And from there, Gorilla can translate that text to the GraphQL and then plugs it in. Because another cool thing about the Gorilla, actually, I do think it's like a perfect storm project. That's why I decided to kind of take it on, because it's got like the tool use thing. It maybe has that ease of use for new Weaviate users thing. And then it also has like, fine tuning a model to a specific task such that you really compress the
Mm,
model. Like the dream would be that we could get the Gorilla to work in, let's say, 300 million parameters, but as small as possible. And I said that arbitrarily, like
yeah.
however small. So because then it's like way cheaper to serve, it's way faster, and I really want to have skin in the game in understanding LLM products, because I mean, I guess earlier I said that I don't really believe in fine tuning language models, so I guess I've now contradicted myself at the end. But I think some people will want to fine tune language models. So I want to like see it, even though I really doubt this will be the most common way that people use vector databases. But like Gorilla also has the retrieval augmented training thing where they call it retrieval aware training, but like where you retrieve the API reference, and so you're using the API reference to learn how to, you have the custom schema, the API reference, and the natural language command. So it's a retrieval augmented input that you're fine tuning with. So it also has that part to it. But so yeah, so I wanted to have skin in the game and understanding like what the problems are, and like how do I compress my language model and then serve it for as cheap as possible, because I'm sure that a lot of people building these applications are not super thrilled with their language model bill, and so they're thinking
Right.
about this.
Got
Yeah.
it. Awesome. Yeah. Yeah, I wanted to keep that as the last question because I recently came across your post and I thought that it is an ongoing research and I was very curious to learn it from you. But yeah, but anyway, thank you so much for answering all my questions and helping, me and the rest of the audience to understand what Weaviate is and what RAG is, generative feedback loops, and what all can be done with all these fancy tools. So yeah, thank you so much for your time, Connor. It was lovely chatting with you.
Awesome. Thank you so much, Sanam.
Yeah, have a good day. Bye.